that is using this, we had found the center of gravity by clockwise movements is equal to anti-clockwise movements. We had said that is m1g into x1. If we take the torque about z-axis, m1g into x1 plus m2g into x2 is equal to F into x. And from there, we had made this equation because F is also equal to m1g plus m2g. Now, if the mg is now removed, mg is not there. So over here, if we see that is this x comes out to be m1g x1 plus m2g x2 over m1g plus m2g. So this is the value of x, right? This is how we got the center of gravity. Now if this is not there, so obviously common sense says that is center of gravity will shift. There is only one particle, so center of gravity should shift only to x1 only. So is it there something that is, if this particle is now removed, can we do something about this expression and we reach that is what is going to be the center of gravity? Over here if we see, that is it had the two particles, these two point systems, they were there, so this would have been the torque, total torque. Now if this is removed, it means from this we have to subtract the contribution of m2g from this one, torque. So that means from this, that is from this, we should m2g into x2, that should be subtracted. When this is subtracted, this is not there. Similarly from F also, we have to subtract the contribution of the force, that is m2g, that is from here we have to subtract the m2g. So if this get cancelled, so this and this get cancelled, this get cancelled, so it comes out to m1g x1 over m1g, so that is x becomes equal to x1. That is what this thing like. That is we can say by sheer common sense also. But why we have done it? What is the use like? Use is, we can use this basic understanding, a basic concept in finding the center of mass of the systems from where the some mass it has been extracted, some mass has been cut. Like we shall be using the same concept right now what we understood in finding the center of mass of a disk. Initially it was of mass m and radius r, this was a whole disk, and now a portion has been cut from this end of radius r by 2. And we are asked to find the center of mass of this remaining disk, that is where is going to be the center of mass. So as we just did, we can find that is xcm is going to be m1 x1, that is had it been complete disk, then m1 x1 minus m2 x2 over m1 minus m2. What does it mean? It means that is if we take this whole disk, this means first we take this whole disk, so its coordinates, x coordinates of center of mass is r0. Before we proceed on this, let's find out the mass of this cut portion. We know if the radius is r, the mass we know that it has been distributed over the area. So it means when the area is pi r square, the total mass of the disk is m. So it means for per unit area, it is m upon pi r square. And what is the mass of this cut portion of this radius which has got r by 2? What is that? That is mass per unit area into area of this. This is going to be pi into r by 2 square. So this is going to pi get cancelled. So this is r square by 4. So this is m by r square into r square by 4. So this comes out to be m by 4. So mass of this cut portion is going to be m by 4. So now how to proceed further? Once again, because this is distributed over area, so as we had just done, so we can say xcm or x bar is going to be a1 x1. Now because this has been cut, when we say a1 x1, this is of this complete disk over which, in which we have a contribution of this also, so this has to be subtracted, minus a2 x2 over a1 minus a2. Because the thickness is same, the density is same, so the formula we just did, that is m1 x1 minus m2 x2 over m1 minus m2, it takes a form a1 x1 minus a2 x2 over a1 minus a2, right? Because mass is equal to volume into density, volume is area into thickness, and density is same of this or this, thickness is also same, so that gets the form a1 x1 minus a2 x2 over a1 minus a2. So what is the area of this? When we say A1, A1 is the complete area of this bigger disk. What is that? It is going to be pi r square. What is x1? Now x1 is of this bigger disk is what? From here to here, we are talking about the x coordinate. This is going to be r0, obviously on the symmetrical axis. So it is r minus a2. Area of this is what? Pi r by 2 square. This is a2. And what is x2? x2 is from here to here. That is r plus r by 2. That is r plus r by 2. So a1 x1 minus a2 x2 over a1 minus a2. That is a1 minus pi r by 2 square. From there we can get the value of xcm, we can find it. If we have to find the center of mass of any system, and if we can see a symmetrical axis and rather two symmetrical axes, the job becomes much easier. Like over here, if suppose we have a lamina, square lamina, do we have any axis symmetry? Yes, we have. We have plenty of axis symmetry, and the center of mass will always lie on the axis of symmetry. So it means if this is symmetrical about this axis, so center of mass will lie over here. Similarly, it is also symmetrical about this axis also. So the center of mass will lie on the intersection of these two axes. If we get two axes of symmetry, that is wonderful. It is going to, center of mass is going to lie on the intersection of these two axes of symmetry. Same way, this is also axis of symmetry, this is also axis of symmetry. Any two axes you can take it as. You can take, if this is square lamina, so one axis you can take it like this, the other axis you can take it like this. This is your choice. Similarly, if this is a cone, if this is a right circular cone, if this is a right circular cone, so this is axis of symmetry is like this. So center of mass will be on this axis only. That is maybe towards, not in the half, in the middle, but it will somewhere over here. But the center of mass will lie on the axis of symmetry if it has one.